Okay guys, in this video I'm going to show you an example on graphing the following equation. H of x equals 4 sine of 3x plus 3 pi minus 2. I went ahead and added one level of difficulty to this problem, where you can see inside of the parentheses the 3, I actually distributed it into the values x and pi. You would notice from our original equation that value that multiplies to k, it's not distributed. Like in this equation, k was not distributed to x and c. We want x just by itself, and then plus whatever value, but x should be there should be no value next to x. It should be just x. In this problem we see that we have that 3 there next to x, so our goal would actually be to rewrite this function so that the 3 is not next to x, and to get rid of that 3 I'm just going to factor 3 out of it. So if I factor 3 out, then x will be left just as x, and then pi will be left just as pi. And you can double check that if you distribute the 3 back in, you will get back the 3x plus 3 pi. So this is the setup that we want to have. We want to have the setup where x is by itself. Alright, the one misconception that a lot of students would get wrong, it's that they would try to graph something like this inside, and they would treat k as 3, which that would be right, but then they would think that the horizontal shift or the phase shift is 3 pi, which in this case you can see that the phase shift is actually pi just by itself. So this is what you want to have, alright, and you get it by factoring that number next to x. So now let's go ahead and graph this. Again, I'm going to do this by steps. And I'm going to list all of the steps that I take to graph this. So the very first step is going to be to graph the midline, which the midline we find it either by adding or subtracting a value to my function. And you can see that in this case I'm subtracting minus 2. So that means that at minus 2, that's where my midline is going to be located. So right here, this is my midline at minus 2. There you go. That is my midline at minus 2. And that would be, you can say, step 1. Alright, step 1. Alright, now the step 2 is I'm just going to define the vertical limits. So I'm going to graph the amplitude. Alright, let's call this step 2. Step 2 is the amplitude. It's going to be 4 units. So from the midline I want to go 4 units up. From the midline I want to go 4 units down. So 2 units up from the midline, that'll take me 1, 2, 3, 4 units. That's going to be the highest point that my graph is going to go. And from the midline down, that's going to be 1, 2, 3, 4. At minus 6, that's going to be the lowest my graph will go. So that will be step 2. Now step 3, which is a little confusing. Let me try to explain it as best as I can. Is going to be the phase shift, or my horizontal shift. Okay, this will be my step 3. So in step 3, here's what I want to do. I want to identify a specific point on my graph, and for sine, that specific point for sine, which this is a sine function, that specific point, it's right there at the origin. If you take a look at the graph of sine, you will notice that right there at the origin, between the y-axis and the midline, we have that increasing portion of the graph going up like this. So I'm just focusing on this part. Alright, so in my original function, again, I will have this. But you will notice that this part, it's going to be shifted pi units to the left. So I want to take this piece of my function and shift it pi units to the left. So you can see here's pi. If I go pi units to the left, I'm technically going right here at negative pi. So right here, now this portion of the graph was actually shifted. I took it and I shifted it pi units to the left. Now I can actually erase this one because it was shifted to the left. It's not there anymore. It shifted to the left pi units. Alright, so that's technically step 3. And you may be thinking, well, that's a weird step, like we just did a little marking, but let's keep going. The next step is now going to be my k value. Remember, this is k, and k helps us find our period. So right here I'm saying that k equals 3. Well, if k equals 3, and I know that period is equals to 2 pi divided by k, then that means that the period is 2 pi over 3. So 2/3 of pi. This may be a little weird to graph, but you can actually put the 2/3 of pi, because these things are going by pi's. And technically, 1/3 of pi would be, well, this is half. 1/3 of it could be some of these points here, like 1/3 of pi. We have 2/3. It's not very accurate. But we want 2/3 of pi. So this thing has to shift 2/3 to the, well, it's not shifting, but the period it's going to be 2/3 of pi. So that means, well, what I want to do is this piece right here, from pi to 0, it's a whole pi. So what I want to do is divide this portion, which is a whole pi, I want to divide it into 3 pieces. So I can actually use my ruler. You can see it's from 0 to pi. I actually have 2.5 centimeters. 2.5 centimeters. I want a third of that, so I can just divide this by 3, and 2.5 divided by 3, that gives me about 0.8. So about 0.8 millimeters, that will actually be a third of pi. And let me show you, this is about 0.8. So over here, this is 10, so I need to go 2 little tick marks. So that's 0.8. I want to go another 8 tick marks to the right, 2, and 6, 7, 8. That'll be the other third. So technically, of this whole pi, this is minus a third of pi, and this is minus 2/3 of pi. But again, this value that we got for our period, that's the distance for this piece. Notice if I go back to my graph, our period for a graph for sine is 2 pi, which means that the distance where this little piece was, I just drew it again 2 pi units this way. You can see the 2 pi from 0, that's 2 pi. another 2 pi units, which that'll be 4 pi, I drew it again. You can see it going up. So that's what I want to do. Every 2/3 of pi, I'm going to draw this piece. So this is 1/3, this is 2/3. So right here at 2/3, I'm going to have this little line again. Then 1/3 and then 2/3 again. Now these thirds, I'm just estimating them. So you can say this is 1/3 of pi, pi over 3. This will be 2/3 of pi. And technically right here at pi, that would be 3/3 of pi. But you know, 3/3 of pi, that's just pi. Again, every 2/3 I want to draw this line. So 1/3, 2/3. 1/3, 2/3. So what are these little lines for? Well, technically this is going to be, and maybe I needed to make them a little more steep, but this is where the line has to, it's going to be increasing. It'll be increasing over here. It's going to reach the highest. It's going to come down all the way to the bottom, well, all the way to 6. I kind of went past through it. And then it's going to go up here. Again, you can see I should have made it a little more steep, but then it's going to go up to the highest point. It's going to come back down to the lowest point, and then it's going to go back up, and it's going to have to go through that point. And it's going to be repeating this motion again and again. Again, you can see I'm just trying to make it so that my graph goes through that little line. And of course it's going to happen the same way, the same thing this way. So it's not a very pretty graph, but we technically got everything right. You can see my amplitude from the midline up, it's 4 units. The graph, so that's my amplitude. My graph was shifted 2 units down. That is that. My graph was shifted pi units to the left. It's that. And of course, my period is 2 pi over 3. Every 2/3, 1/3, every 2/3 of pi, my graph is increasing. Another 2/3, you can see my graph is increasing. Another 2/3, you can see my graph is increasing. So technically this is how the graph looks like, and this is how you would graph it. Again, just to reiterate, I'm working with sine, the graph of sine. So I started drawing that little piece of sine, which I know goes through the origin. Then I shifted the graph based on step 3. I shifted the graph this many units, in this case pi units, to the left. So this thing, this piece, I shifted it pi units to the left. I kept it there because it's gonna stay there, and then I found the period. So I used k to help me find a period, which we got it to be 2 pi over 3. That's my period. Then what I did, I just measured 2/3 of pi this way. That's 2/3 of pi. The distance from here to here has to be 2/3 of pi. Then the distance from here to here has to be another 2/3 of pi. And again, the distance from here to here has to be another 2/3 of pi. You will see that. Also, if you notice this distance right here, again, which is 2/3 of pi from here to here, that distance is 2 pi over 3. Not only will you notice that, but also you will notice that halfway through that point, the graph will intersect. the midline. You will notice in this one as well, the distance from here to here is also 2 pi over 3. And right there at the middle, actually my graph should have gone through this middle. And that's technically the pattern over and over. And again, this is another 2/3 of pi. That distance is 2/3 of pi. And this is how you want to graph this. Again, right in the middle, you can see that's where the graph intersects the midline again. And that's it. That's how you would graph these functions piece by piece.